Good day, guys. Welcome to the channel. Please, before we go any further, do not forget to like, subscribe, and share the channel with your friends. Okay. Today we are going to deal with organic chemistry. Basically, the introduction part of it. Okay. So you can ask yourself, what is organic chemistry? Now, organic chemistry consists of what we call organic molecules. Alright, so when we talk about organic molecules, we talk about molecules that consist of carbon as a backbone. So the most simplest molecule of an organic molecule is the one that you see on the screen, and its name is called methane. So this molecule you see on the board falls under a family of molecules called the alkanes. So now the names of the families that we are going to use, we are going to call them it's called the homologous series. Okay, homologous. Homologous series. So now the word homologous series, it is used to refer to the group of atoms or group of molecules that fall within a certain family. For example, we are going to refer as the alkanes as a homologous series, the word alkane. So alkanes are categorized by the single bonds between the carbon and hydrogen atoms only. So the homologous series of alkanes consists of molecules that only contains carbon atoms and hydrogen atoms, and everywhere you see single bonds, and we say these kind of molecules are saturated. I'm going to explain this later. So the word saturated means that it consists of all single bonds, so there is no addition reaction that's going to take place. Okay, now we can move to the second stage of this family. We call them the alkenes. Alkenes is another form of homologous series that we are going to deal with, but now alkenes are slightly different from alkanes, such that in between at least two carbon atoms you must see a double bond. Okay, so this is an example of an alkene, and it is the most basic one. So you cannot have an alkene with less than two carbons, because you need a double bond in between carbon atoms for a molecule to form an alkene, right? So in the process of explaining, bear in mind that it consists of double bonds. So the ones that consisted of single bond, we said it is saturated because we cannot add any more atoms. Now this one, since it contains double bonds, we say it is unsaturated. Saturated because it consists more multiple bonds. All right, now the group of atoms that you see here, we will call them a functional group. The word functional group. Okay, sorry with my network. So we will call them a functional group. So functional group are the group of atoms that determines a specific behavior of a molecule. It may be chemical or physical properties. For example, this group of atoms will determine the boiling point of a molecule. They will determine the viscosity of a molecule, volatility of a molecule, and so forth. Okay, so we call those group of atoms a functional group. So they define a functional characteristic of that particular molecule. So multiple molecules within a homologous series, they will only differ with the chain length or configuration of the chain, but they will have the same functional group. So all those molecules that have the same functional group will fall within the same homologous series or a family name. Okay, for example, you may have a family name of Smith or Cosa, but inside the same family name there will be boys, there will be girls, and so forth. There will be elders, there will be youngsters, but you guys share the same family name. Okay, so the same analogy can be applied here. Now let us move on. We have alkynes. Sorry, let me go back to my original color. So now we will have the alkynes. Now alkynes are different also from the alkenes by doing what? By adding another bond. So alkynes, they have a triple bond in between two carbon atoms. So the lowest number of carbons that you can have is 2, because you need the triple bonds between carbon atoms. Okay, then also they are unsaturated. They are also unsaturated. Remember, I said the word unsaturated refers to the fact that they have a multiple bond. Multiple bond meaning that it's not a single bond like here. Okay, this is a double bond, it's a multiple bond. Triple bond, it's also multiple bond. Okay, so you can also understand the word saturated or unsaturated as when it's unsaturated, you can add. So you can add more atoms to break these triple bonds. Okay, now we also have homologous series called the haloalkanes. Haloalkanes. So this explains itself. The word halo, it is derived from group number 7 elements for halogens. Now alkanes is that one over there. So meaning that it will have halogens and alkenes. An example of this will be a carbon bonded to Cl, then also bonded to other hydrogen atoms. So it has a halogen and the other part of the molecule looks like an alkane. So bear in mind, it can have more than one type of halogen. You can have Cl, you can have an F there, then an H, and an H. So you are not limited to have only one. Okay, so we will continue with naming at a later stage. We will also have what we call an alcohol. We will have what is known as alcohols. So how do you see alcohols? Alcohols, they can also have one carbon, but they must also have an OH. Okay, they must have an OH. So what is the name of this OH? It has a name. So this OH here has a name, and it is called an hydroxyl group. It is called a hydroxyl group. Okay, hydro, there's an R there. Let me rub. Okay, yes, it will be called a hydroxyl. Okay, so it is called a hydroxyl group. The OH here, a C connected to an OH, it is called a functional group. Okay, when we now consider the C, it is now called a functional group. Okay, so the name of this functional group, it is called a hydroxyl. So they might ask you for the functional group, you can throw it, but if they say the name of the functional group, you must be able to specify that it's an hydroxyl group. All right, we will see more of alcohols when we do esterifications and so forth. Now from here we have what we call ketones. Let me change back to blue. We have what we call the ketones. Now ketones, they have a minimum of 3 carbons, and I will show you why. So there must be a carbon bonded to 2 other carbons that will have a carbonyl group. Okay, so this is the most basic ketone you will ever see, a ketone with 3 carbon atoms. Then this is the functional group of a ketone, and we call that a carbonyl group. Carbonyl group. Okay, that is the name of the functional group of ketones. Now ketones is not the only homologous series. Remember, the names that I'm writing here, I call them homologous series. They are family names. Alright, so ketones is not the only one that has a carbonyl group as a functional group. There is another family name called aldehydes. So it is called aldehydes. So aldehydes looks like a ketone, but the difference is that the functional group is at the end of the molecule. Okay, so aldehydes, they can have 1 carbon, nothing stops them, and they can have 2. So I'm going to draw the one with 2. Okay, so this is an aldehyde. So the difference is that the functional group is at the end. The functional group is at the end. Here it's in the middle. Here is at the end. So later on I will teach you about isomers, and then why ketones and aldehydes are isomers. Okay. Now we also have what we call carboxylic acids. We also have what we call carboxylic acids. Now with carboxylic acids looks like this. It has a double bond O, and then OH, in it. It has a double bond O and an OH in it. Okay, now the functional group of a carboxylic acid is this one. That is the functional group of a carboxylic acid. If you can look properly, it has both a carbonyl and a carboxyl group. Now, I want you to bear in mind of a certain pattern. Look how many bonds surround carbon. We have 1, 2, 3, 4. 1, 2, 3, 4. If we go up around all carbons, we have 1, 2, 3, 4. 1, 2, 3, and 4. So surrounding all carbons, you are going to have 4 bonds. 1, 2, 3, and 4. So all carbon atoms must have 4 bonds around it. More than that, you are breaking the laws. Okay, and then lastly but not least, we have esters. Okay, this is a process that we are going to learn extensively here. So what does an ester look like? So an ester must have a minimum of 2 carbons. So we will have a C, an O, and another C double bonded to an O. Then here we will have like this, like that, and then we will have an H. Okay, so this is called an ester. So how do you see an ester and how do you characterize it away from a carboxylic acid? So you can see it forms this boat shape here. It forms this boat shape here as a functional group. Looking at the carboxylic acid, it's at the end, but this one, the functional group, is in the middle of a molecule. Okay, so both carboxylic acid and esters are isomers. What kind of isomers I will explain later on. Okay, now you might need to know, how do we come about the names of these particular molecules? Firstly, you must start to know how to characterize a chain. Okay, a chain, we talk about a number of carbon atoms a specific molecule has. Okay, so we are going to deal with the longest of 8 carbons. So 1, 2, 3, 4, 5, 6, 7, and 8. So 1, we will say it's meth. Then 2, it's eth. 3, it's going to be prop. 4, it's going to be but. 5 is going to be pent. 6, it's going to be hex. 7, it's going to be head. Lastly, 8, because the longest chain you're going to deal with, it's 8, it's going to be oct. Okay, now this is what we call the chain length of a molecule. If it has 1 carbon, it is going to be called a meth. Of course, this is not the full name. Then 2 carbons, eth. 3, we are going to use the word prop. 4, but. Now, if you go back, I said a molecule with only single bonds around it, it's called an alkane. Okay, now let us visit a homologous series of alkanes. and then learn about the naming. Okay, so using alkanes, an alkane has a suffix of A and E. So when you are dealing with an alkane, you are going to have a suffix of A and E. Okay, then now let us try to figure out how many carbons do we have here. Now let us count 1, 2, and 3. So we have 3 carbons, meaning that we need to use prop. So the name will be prop for the 3 carbons. Now because of it's an alkane, we are going to put the rest of the name here, A and E as the suffix. We call this the suffix. Okay, so the full name of this molecule will be propane. So prop for 3 carbons, then A and E for the functional group, because it falls under the Alkanes homologous series. Okay, now what happens if we add another carbon? If I add another carbon here, I must have that H, then I will put another C, then H, H, H. So now it's going to have how many carbons? 4. So now it's going to have 4 carbons. So what is the longest chain of the 4 carbons? It is bute. So we are going to say bute, then we take the suffix, we put it there. So the name becomes butane. Okay, so that this is when we are dealing with what? The alkanes. This one, remember I said that they only consist of single bonds, like here in between what? A carbon and hydrogen atom. Now from here we have a formula to check how many of what atoms are there in the molecule. Okay, we have a formula that we can use to determine how many atoms of each molecules are there. So let us count now. I'm going to use a different color. So we have already figured out that we have how many carbons? 4. Now how many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have H 10. So now if ever you want to determine an unknown, because or a general formula, remember the word general. So a general formula, so the word general means it must work for any molecule in this homologous series. So it will be Cn. So let's assume that you don't know the number of chains, so it's Cn. Okay, then H. So 10 is more than twice of 4, so it's going to be CnH2n. So if we multiply 4 by 2, then it's going to be 8. How many hydrogens will be left? It is plus 2. Is it? So let us go back to propane and see if this is true. So I'm going to rub here. I'm going to rub, sorry. Okay, then now we put the H there. Okay, so how many carbons? Carbons are 3. So we counted up until 7, then we have 8. So now what is the chain? So we have C3H8. This is we call this a molecular formula. We call this molecular formula. So in the molecular formula, you can see exactly how many atoms of each element are there in the molecule. Okay, so we know we have 3 carbons, 8 hydrogens. But how does it satisfy this general formula? Let us see. Cn, okay, now since n is 3, so H2 times 3 is 6 plus 2 is 8. Then we have that 8. Yes, the general formula suits. So this is going to be the general formula for alkenes. Okay, so we call that a general formula. Now, can I rub? Okay. Now we are going to deal with something called a condensed structural formula. Now you must ask yourself, what do we mean by saying a condensed structural formula? Okay, I think we are done. Now, what do we mean by saying condensed structural formula? So a condensed structural formula for the molecule you are seeing on the board, it is some kind of a summary of a structural formula. So you reduce it. Now we have a carbon. How many hydrogens bonded to that carbon is 3. Okay, then we have another carbon which is C, then H2, then we have another CH3. So this is called the condensed structural formula. So it doesn't show bonds, but it shows exactly how the molecules are bonded to each other. Then we have a partially condensed structural formula. Why don't we show you that here maybe we have a CH3 and another CH2 and another CH3. So here you can see that you haven't completely removed all your bonds, but it's still a condensed structural formula, so it is partially condensed. Okay, now can we move to another homologous series? Okay, now we are going to deal with alkenes. Okay, sorry. Okay, I'm sorry. Let me unplug this. Okay, yes, so we are going to deal with alkenes. Now alkenes, they have a suffix of E and E. In this case, remember, alkenes, they are the ones that have a double bond up there, we can go up there to check what are alkenes. Okay, they are the hydrocarbons that we deal with in the second part here. Okay, so the second part is the alkene. If you can look at this properly here we are dealing with alkenes. So what did we say alkenes contains? They contain a double bond. Okay, now let us check. Now, how do we deal with the problems of alkenes? Okay, now alkenes, they have, let's see, for example, we'll have 1, 2 and 3. Okay, I will say 4 for argument's sake. Now I will put a double bond here. Please remember, guys, that around every carbon atom there must be what we call 4 bonds around it. Now for argument's sake, I'm sorry, I'm struggling with something here. Okay, no problem. So now we are going to have an H, another H here, then a bond, and an H, 2 H's there, a bond, and 3 H's there. Okay, now we call the molecule that you see on the screen an alkene. Now, how do we name and number this molecule? So now this is where we take naming seriously. Now we want to determine the longest carbon chain so that we can determine the name. Okay, but now how do we go about that? The number of carbons is 4, but how do you number 4? Do you say like 4 in this instance? Okay, okay, yes, I'm going to choose green. So do we say in this instance that is it 1, 2, 3, 4, or is it 1, 2, 3, 4? Now this is where we start to create rules so that naming can be much easier. So for us to create rules, number 1, when you name or when you number from the side that is closest to your functional group. Okay, so in this case we have a double bond, so we are going to number from the side that is closest to the double bond, which is the left hand side. And another thing is that we need to make sure that the functional group has the lowest number possible. If we name from the right to the left, the bond will be at carbon number 4, but if we name from the left to the right, it's going to be at carbon number 1. Okay, so the naming is the one at the top, the numbering. So this one doesn't apply in this instance. Okay, So let us get rid of it. Let us get rid of it. Let us get rid of it. And that. Now, number 2, what is the longest chain? So we can clearly see by numbering that it has 4 carbons, so it's going to be bute. So we write that bute, and then the suffix is in, so it is butene. But now this is not the end. Between the chain name and the suffix, you need to tell us which position is our double bond. So this double bond is at position -1 -in. So between each word you put a dash and you tell us the position of the double bond. Now I'm going to make things interesting. I'm going to remove this double bond there and throw it into a new location. So now let's say the double bond is here. Okay, so can you see now that the double bond is at position number 2? So we cannot just say it's butene by not telling where, because it is not at the same position as the last time. So even here you need to tell us that, okay, the chain name is 4, then we have a double bond, but where is the double bond? Position number 2, then in, to show that it's a double bond. So position number 2 is the position of a functional group. What kind of functional group? We check the suffix, then it's going to tell us that it's a double bond. Okay, then we have an alkyl group. Now alkyl is similar to alkenes with an exception that it's a triple bond. Now let us rub here and determine the alkynes. Okay, let me rub everything. Alright, so now we are dealing with the alkynes. So alkynes has a suffix of y and e, okay, and it's a triple bond. Now one, show the triple bond, and see there. So the molecule will look like this. Okay, and then the name of this molecule, we are going to check the chain. We can see there's 3 carbons, so it has the word prop. Okay, just like the numbering that I've done previously, we check the position 1, 2, 3. So the triple bond is at position number, carbon number 1. So you need to specify -1 dash, then the suffix is y and e. So it is propyne, but you need to show that it's prop -1 dash wine because of the position number 1 of the triple bond. Similarly, if you increase the chain and move it to position number 2, you are going to change this into 2. Okay, and bear in mind, you are not obliged to number from the left. So we can have a molecule like this: 1, 2, 3, 4, and 5. Then I put my triple bond here. H, 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 H. Remember, around every carbon there must only be how many bonds? 4 bonds. Okay, now I've already counted when I was drawing that there are 5 carbons, but remember we must number from the side that is closest to the triple bond so that the triple bond can have the lowest number possible of carbons. So here we have 1, 2, 3, 4 and 5. The vice versa is 1, 2, 3, 4 and 5. So if we move from left to the right, the double bond is at position 3, but if we moved from right to left, it's at position 2. And therefore the right to left is the correct approach. So the name, it has 5 carbons, so 5 is pent, so we are going to write pent. It's a triple bond at position 2, so we show 2 dash then the suffix. So it's not always a must for you to number from the left to the right. Now we have something called the alkyl halides. We call them the branches. Okay, so what are the alkyl halides? What are the alkyl halides? Okay, I think now it's slightly clean. The rest will just remove themselves. Now alkyl halides are what we call the branches, not alkyl halides but the alkyl group, sorry, the alkyl group. It's what we call the branches. Now instead of having a straight branch, I'm going to start with the alkanes. We can have a branch like this: 1, 2, 3, 4. Then we have another carbon chain that is there. Okay, okay, we may have a molecule that looks like this. Now let us determine the longest continuous carbon chain here. Now if we number from the left to the right, it's going to be 1, 2, 3 and 4. Okay, so the longest is 4 carbons, but it doesn't mean that always your numbering must be straight. You can number from here, it will be 1, then 2, then 3, then 4. So your chain must not always be straight. It's not a must not, but it doesn't have to be. If it is at an angle, you are welcome to keep it that way. Okay, so in this case we can see that the longest chain is 4. Okay, so that means we are going to have a but. Okay, and then here we don't have a functional group because it's a single chain, single bonds everywhere, so it's going to be butane. Right, but at position number 2 something is there. What do we call this thing? Okay, so we call this the alkyl group or the branch. So since it has one carbon, we are going to call them a methyl. Okay, then if it can have a 2 carbons, we will call that one eth. Remember, 2 is eth. Okay, so we are going to call that one ethyl. But in this case, we are not dealing with ethyl, we are dealing with 2, with 1 I mean. So at position number 2 dash, what do we have? We have a methyl. So the full name will be 2-methyl butane. Okay, let me give you another example so that you can get to understand what's happening here. Okay, now let's say we have the following molecule. We have 1, 2, like this. Okay, okay, then we also have okay, like this. Okay, sorry, I'm not going to have that now. Then we also have this. Okay, now I'm connecting all the carbons. Okay, okay, this is the molecule that we have now. So now it looks kind of complicated, but now it really isn't. So now let us count. Okay, if we can count from the right to the left, 1, 2, 3, 4, 5, 6. Longest is 6. Even if we go back, it's 6. But now, if we go from right to left, this branch will be at carbon number 4. But if we move from the left to the right, it will be at carbon number 3. So remember, I said we want it to have the lowest number possible. So we are going to move from the left to the right. Okay, let us check if we move from here. 1, 2, 3, 4, 5, 6. Okay, even if I move from here, it's going to be 1, 2, 3, 4, 5, 6. So it doesn't matter if I come at an angle or straight. So the longest continuous carbon chain has 6 carbons, so it's going to be hex. Okay, hexane, because it's only single bonds, it doesn't have a functional group. Now, but at position number 3, something is interesting. We have two branches. We have a branch that has 2 carbons and another branch that has 1 carbon. So what will be the name? Now the name now will be prioritized according to the alphabetical order. So between E for ethyl and M for methyl, what comes first in the alphabetical order? So E comes first before M, which comes second. So we will say at position number 3, we do have an ethyl. Okay, then again at position number 3, if between words we need dashes, we have a methyl. So an ethyl is written before a methyl. Okay, so it's 3 dash ethyl dash 3 dash methyl hexane. So that will be the name of this. So guys, ladies and gentlemen, please practice. On the next session we are going to continue with naming. Specifically we will